let's take a look at the remaining topics. So the remaining topics about the multiple vertices. So in this case, we need paths. A path in a graph of ranks n is the list of edges with vertices next to each other. And maybe if you have a relation on this set A, there is a path of ranks n from A to B if and only A and B pair in R n. So that means you have path A to B. A simple path is about R1, and that is same to R. If there is another path A, C, B, that is R squared, because you have one more vertex between those two. Anyway, this is about paths, and this is kind of relation. So how can we say this kind of connection? Oh, so how can we say the vertices are connected? So if there is two vertices in the graph, uh, and they are connected if only if there is a path between them, like previous example. So we can make a general uh, term for this. That is R star. So this is about the connectivity. So we can say this connectivity relation. So connectivity relation R star is about R, and that is consists of the pairs A and B, such that there is a path from A to B in R. So in this case, we can use any number of vertices between those. So anyway, you can connect them together with the paths. That is a connectivity relation. So that's why we can rewrite this in this equation. The R star is about the combination of from 0 to infinite R. So again, we have seen this kind of property of relation reflexive about the self relation A and A, symmetric about so replacing their order. A B is available, BA also available. Transitive is about the connection. If there is a node, we can make connection. So that's why we can define the connectivity relation using it. So here is that definition: transitive reflexive closure. Yeah, if you have a relation or set that has the property like reflexive, that is reflexive closure. We can use reflexive property on that. If there is transitive properties on the relation or set, we can say that is transitive closure. But if a set of relation is available, those two property simultaneously, like transitive and reflexive, we can call this transitive reflexive closure. So transitive reflexive closure of your relation is the connectivity relation R star. So here is that. Here is the R. So you want to write R star. So you need to make sure that information. So you need to add some edges to make sure that properties. So for the reflexive, you can add this self relation first, self loop, so they can show reflexivity, and so you can add more edge to make sure the transitive. Then you can describe the connectivity relation of the relation R. So there's another relation. So we have seen binary relation, that is about this Cartesian product. Here you have two set, and there is Cartesian product, and you can make a pair like this. But if you have multiple set, so you can make a unary or n-ary relation, binary or ternary, all kind of relation using it. So for example, there is a set A, B, C, and 1, 2, 3, and upper, beta, gamma, and triangle, rectangle, circle. So this is binary relation. We can add more line into this, another ternary, and then we can make one more thing. So you can make this kind of relation. It can make another path. So if you see a single part like this, they are all binary relation, but anyway, if you combine them together, it's n-ary relation. Okay, let's looking at the example of this relation. In database, we can use this kind of relation. So here is student table. It has student name, ID number, office, and GPA. So we can store all the information of student for this office and GPA. But if you want to store another information like courses, so maybe it requires multiple row for each course, and you may need to add this course column here like this. But there is some issue. It has some duplicated information here and there and here again. So this is not looks good. So anyway, the table is so big, and there is some duplicated information, and it is much more than courses. So we want to store one more course, but we may need to store this many information. So how to solve this issue? We can use relational database using two table and primary key, ID number here and here. So in this case, if we can connect these two tables with relation, in that case, we have to use a common information ID number, that is a primary key, so we can combine them together with that key, and we can use several database operation to extract this kind of information. The first one is projection. So you want to extract single information, single column information. We can use pi office. We can get office information from the table. We can also try to use multiple information like office and GPA. So we will get this information without other information. This is combination with office and GPA. And the more general thing is selection. So if you want to get special condition to extract all the information from the table. So you can use selection. So here is the condition we have this condition GPA is greater than 3.9. So we can get all the students that has this high GPA. So sigma GPA that is greater than 3.9 student table, we will get these two student information. And we want to extract more information, or we want to limit the information. So we can use projection again. So here is the limitation. We want to looking at name and GPA only because ID number and office is in usually in this case. So we can combine them together like the composition. This selection first, then apply the projection. We will get this table. Last operation is retro join. There are several join, but this is typical. In this case, we can reconstruct the first table, which is a little bit complex, so that's why we want to divide it in two parts, but sometimes you want to see all the information in a single table. In this case, you can combine those two tables with your ID. In this case, we here have a single ID column, but you will see this repeated information here and there, and there will be more information at the end of this table. So you can simply combine two tables using relation and this operation, retro join operation. Then you will reconstruct this single table to see all the information at once. Okay, this is end of this topic. We're going to cover finite state machine from next week.